Question number 1 says a light inextensible string has a particle A of mass 0.26 kg attached to one end of the particle and a particle B of mass 0.54 kg is attached to the other end. I'm extracting this diagram here. This is the case. Angle is alpha. Particle A lies here. This is the pulley. B hangs on the other side. And the mass of particle A is 0.26, so weight would be 2.6. And mass of particle B is 0.54, so weight of particle B would be 5.4 newtons. Attached to the other end, the particle A is held at rest on a rough plane inclined at an angle alpha to the horizontal, where sine alpha is equals to 5/13. So sine alpha is given, that is 5/13. We will use this later. This is alpha. Sine is perpendicular over hypotenuse. So if I use Pythagoras theorem, that is 13 square minus 5 square whole square root, I get this side as 12. So I can use sine, cos, tan, anything. The string is taut and parallel to the line of greater slope of the plane. The string passes over a smooth pulley at the top of the plane. Particle B hangs at rest vertically below the pulley as shown in the diagram. The coefficient of friction between A and the plane is 0.2. Particle A is released and the particles start to move. B is heavier, B would come down. And the question says find the magnitude of acceleration of the particles and the tension in the string. So mu is given 0.2. Now let's get started. B is perfectly vertical, so we don't need to resolve that, and I'm resolving A. Alpha is there, this is alpha, this is going to be 2.6 cos of alpha, this is going to be 2.6 sine of alpha, this is particle A, that is particle B. Now we write the equations. For particle A, which is moving up, obviously tension would be more than the resistive forces. So tension minus 2.6 sine alpha, which is component of weight opposing the motion, and do not forget that it was rough, so there is friction as well, minus mu r is equals to ma. Now we plug in all the values we know. Minus 2.6 sine alpha was given in question, that was 5/13. So sine alpha is 5/13 minus mu was given, that is 0.2. We can find r. R is this, in this case that is equal to 2.6 cos alpha. There is no other force in this direction. So r is 2.6 cos of alpha. Using the same triangle, cos alpha is 12/13. 12/13. Mass is 0.26 and A. The only unknown in this equation is T and A. I'm simplifying the equation. T, now 2.6 into 5 divided by 13 gives me 1. Minus 1 minus 0.2 into 2.6 into 12 divided by 13 gives me 12/25 is equals to 0.26 A. I'm making T the subject of the formula right here. So 0.26 acceleration, adding those two, 12 divided by 25 plus 1 gives me 37/25, which is 1.48. So we get this equation from particle A. Now I'm making equation for particle B. It is very clear that it is moving down, so that means weight is more than the tension and equals to ma. F equals ma, net force equals ma. Weight is 5.4, tension is unknown, mass is 0.54 and A. So we already made T the subject. We can replace all of this right here. 5.4 minus The tension is 0.26 A plus 1.48 is equals to 0.54 A acceleration. So 5.4 minus 0.26 A minus 1.48 is equals to 0.54 A. So 5.4 minus 1.48, we're left with 3.92. This goes on the other side and gets added. 0.26 plus 0.54 is 0.8 A. So acceleration is 3.92 divided by 0.8, and we get 4.9 meters per second square. Once the acceleration is done, we can substitute the same value to find the tension, and we use the same equation, the simplified one. So tension is equals to 0.26 into acceleration 4.9 plus 1.48, and I'm getting 0.26 into 4.9 plus 1.48, and the tension is 2.754 Newton in exact form. So that was the first part of the question. Let's see what the second part says. Particle A reaches the pulley 0.4 seconds after starting to move. So all the way till here is 0.4 seconds. Find the distance moved by each of the particle. So I need to find the distance. Time is given. Initial velocity, they were at rest. So I can use the equation S is equals to ut plus half at squared. Initial velocity was 0 and time taken is given, which is 0.4 plus half we just done with the acceleration, which is 4.9. So acceleration is 4.9 and time is 0.4 squared. Using calculator, I'm getting 1 by 2 into 4.9 into 0.4 squared, and I get 0.392 meters.